Hello guys, welcome to Chem Fact. Today we are going to discuss about redox reaction. In chemistry there are basically two types of reaction, acid base reaction and redox reaction. But today we will only discuss about redox reaction. So now we have to know what is a redox reaction. Redox reaction is nothing but a chemical reaction in which oxidation as well as reduction occur simultaneously. So you may ask the question, what is oxidation and what is reduction? Oxidation is a process in which electrons are lost. Here we can see an example that Fe2 plus loses an electron to form Fe3 plus. So here oxidation is occurs. Why? Because Fe2 plus lose an electron to form Fe3 plus. And reduction is a process in which some species gain an electron. Here we can see that copper 2 plus accept 2 electron to form elemental copper. So it is a reduction reaction as copper 2 plus accept 2 electron, not remove. In redox reaction, we frequently heard the term oxidation number. So what is it? It is nothing but the number of charges that would be generated on a given atom when the bonding electrons owned by the more electronegative atom to constitute the bond. If the combining atoms are of same electronegativity, then the bonding electrons are shared equally between them. In assigning the oxidation number, the compound is considered to be perfectly ionic, where the bonding electrons are assumed to be completely shifted toward the electronegative atom to form the bond. There are certain rules to determine the oxidation number of a given compound. So let us see what are those. There are several rules. So let's see. The first one is oxidation number of an element in free state is 0. That is, when an compound like copper, that is it is in an its elemental state, or hydrogen H2 or O2 etc. These are in their elemental state or more rather free state, so their oxidation number is 0. And the second rule is the electropositive elements are considered to be bear the positive oxidation number given by their group number, that is alkaline earth metal, alkaline metals. These compounds have positive oxidation number like sodium plus, potassium plus, etc. And the third rule is the electronegative elements are considered to bear negative oxidation number, that is in compound NaCl sodium chloride the oxidation number of chlorine is -1, whereas oxidation number of sodium is +1, so that the total oxidation number, that is the sum of the oxidation number of each constituent, is equal to 0. That is our fourth rule, that the charge of an ion gives the sum of oxidation number of constituent atoms. As I say, in sodium chloride the oxidation number of sodium is +1, and in chlorine and the negative part, that is chloride, the oxidation number of chlorine is -1, that is +1 minus of 1, that is 0. The rule 5, the oxidation number of hydrogen is generally +1, but it becomes -1 in ionic hydride. In ionic hydride we mean sodium hydride. In sodium hydride, the oxidation state of sodium is +1, and sodium is more electropositive than hydrogen. So the oxidation number of sodium is +1, and the oxidation number of hydrogen, or rather we can say hydride, in this compound is -1, and oxidation number of oxygen is generally -2, but in peroxide like H2O2 it is -1, and in superoxide it is -1/2. In fluorides it become +1 for F2O2. These rules will be clear when we solve a problem. So let's go to a problem and learn it. Here the given problem said that we have to calculate the oxidation number of the given species, the underlying species, or rather we say the underlying atoms in the given species. First, number one problem shows a ionic species. We can clearly see from rule number 3 that the sum of the oxidation number of individual atoms is equal to the total charge of the molecule or species. Here that species has -2 charge, that is -2. So the sum of individual oxidation number of the species is equal to -2. We can assume that the oxidation number of sulfur is X for one sulfur, but here 3 sulfur is present, so we have to multiply 3 with X. So let us assume the oxidation number of sulfur is X. Here 3 sulfur is present, so we have to multiply 3 with X, that is 3X. And oxygen in general have oxidation number -2 for each oxygen, but here we have 6 oxygen, so we have to multiply 6 into -2, that is plus 6 into -2, and the sum of these is equal to the total charge of the species, that is here -2, so we can write -2. This is an algebraic equation, so by solving it we can have the value of X, that is the oxidation number of sulfur in the given species. By solving this we can write from here we can see that the oxidation number of sulfur is 10/3, that is it is a fraction, not a whole number. So from this we can conclude that oxidation number can be a fraction also. So the oxidation number of sulfur in is 3062 minus is 10/3. Now we can solve the second problem. Here we have given a species which is neutral. It is phosphoric acid and it is neutral species, as here is no charge, that is it is 0. It is neutral. So sum of the individual oxidation number is equal to 0. And here we have to calculate the oxidation number of phosphorus. So first we assume that the oxidation number of phosphorus is X, like the previous problem. Let us assume the oxidation number of phosphorus is X. As here one phosphorus is present, so we can write simple X plus. Hydrogen in general has oxidation number +1, but here 3 hydrogen is present, so we have to write 3 into 1 plus oxidation. Oxygen has the oxidation number -2, that is -2. As here 4 oxygen is present, we have to multiply 4 into -2, that is 4, equal to 0, as this is a neutral species. This is again an algebraic equation. By solving this, we can have the value of x. Here it is 5. So oxidation number of phosphorus in the given compound is 5. That is plus 5. And now we have to discuss about how we can balance a redox reaction. In the previous the beginning of the video, you have seen a redox reaction which is completely balanced. So you may ask me a question, how can we balance a redox reaction? That can be done by two methods. That is, one is ion electric method or half reaction method, and another is oxidation number method. But today we will only discuss the ion electric method. So what is ion electric method? Let us discuss. In ion electric method, there are several rules. So what are the rules? Let's see. The first rule says that the complete redox reaction has to be divided into two half reactions, one representing oxidation while other representing reduction. The atoms other than oxygen and hydrogen should be balanced first. For a reaction taking place in acidic or neutral medium, every excess of oxygen on one side is balanced by adding equal number of water molecules to the other side, and hydrogens are balanced by adding suitable number of protons. And this is for this rule 3 for A. This is only for neutral or acidic medium, that is for neutral or acidic medium, not for basic medium. For basic medium we have other rule. For basic medium we have for reaction taking place is in any alkaline or basic medium, each excess of oxygen on one side is balanced by adding equal number of water molecules to the same side and double number of hydroxide ion to the other side. In case the hydrogen atoms are still not balanced, they are balanced by adding same number of hydroxide ion to the side excess in hydrogen and same number of water molecules to the other sides. These rules will be more clear when we will solve a problem. So let's do one. In this problem, we have given a redox reaction, but it is not balanced. So we have to check which species is oxidized and which is reduced. So let's do it. Here, the oxidation number of chromium in potassium dichromate is, potassium has 2 into plus 1 plus chromium, let chromium has oxidation number x, and here is 2 chromium, so we have to write 2x, and oxygen has oxidation number minus 2, and here is 7 oxygen, so we have to multiply 7 to it, and the total charge of the species is 0, that is it is neutral, so we have to write is equal to 0. So x is equal to, so x is equal to plus 7, and here chromium has oxidation number plus 3. Here in SO2 oxygen has oxidation number -2, and it is and here is 2 oxygen, so we have to write x plus 2 into -2 is equal to 0. That is x is equal to plus 4. It is plus 4. And in potassium has oxidation number plus 1, and this total species has this total species has the charge -1. So the oxidation number of sulfur will be, hydrogen has oxidation number +1, sulfur is x, and oxygen is -8 is equal to -1. That is x is equal to minus plus 6. It is here plus 6. So here oxidation number increases, so it is a oxidation reaction. And here oxidation number is 7, which decreases to +3, so it is a reduction reaction. So we have to consider only the oxidation reaction and reduction reaction separately. Reduction, we will write first the reduction reaction, that is it. We will only write the ionic form, that is here we will omitted the potassium, which is a salt. Here is 2 chromium, and but here only 1, so we have to multiply 2. And here is 7 oxygen, so we have to add here 7 water molecules, and the total number of hydrogen is here 17 into 2 is 14, so here is 14 hydrogen, but here is none, so we have to write 14 H plus. Now we have to add electrons. Here the total charge is -2 and plus 14, that is plus 12, and here the total charge is plus 6. So we have to add here 6 electrons, so that total charge of left hand side and right hand side will be matched. Now we have to write the oxidation reaction. That is here is only 1 sulfur and here is only 1 sulfur, so we have not adjust the number of sulfur. We have to adjust the number of hydrogen and oxygen. Here is 4 hydrogen and here is 2 hydrogen, so we have to add here 2 H2O molecules. So the number of hydrogen is here 4 and here is 1, so we have to add here 3 H plus, as the number of hydrogen which lacks is 3 this side. Now we have to equalize the number of charges in the both side, that is here the total charge is -1 plus 3, that is plus 2, so we have to remove 2 electrons from this side, that is 2 electron. Here is 2 electron and here is 3 electron, but in a redox reaction the number of electrons change will be same. If a species lose 2 electrons, then another species will accept those 2 electrons, so here the number of electrons has to be equalized, so that so to do that we have to multiply 3 here, that is here we have added electron and here we have abstract electrons. As in oxidation electrons are lost, so here we write negative or negative sign, and as in reduction reaction electrons are accept, so we have to write, we have write here positive sign. Now let us see the problem number 2. Here the oxidation number of bromine is 0 and this reaction is occurs in alkaline medium. Why? Because here potassium hydroxide is used. So it is a basic medium. It is in the basic medium and the oxidation number of elemental bromine is 0, and in caviar the oxidation number of bromine is -1, as bromine is more electronegative than potassium, so the oxidation number of bromine in this compound is -1, and in this compound the oxidation number of bromine is +5. How? If we assume that the oxidation number of bromine is X, then and potassium has oxidation number +1, oxygen has oxidation number -2, but here is 3 oxygen, so we have to multiply 3 and it is equal to 0. From this we can have X is equal to +5, so oxidation number of bromine in this compound is +5. From this we can see that here oxidation number decrease, that is it is reduction reaction, and here oxidation number increase, so it is an oxidation reaction. First we consider the oxidation reaction. Here the number of bromine is 2, but here is 1, so we have to multiply 2. Now we have to balance the number of oxygen or hydrogen. As here is oxygen, so we have to first balance the number of oxygen. That is, here is 6 oxygen. 3 into 2, that is 6 oxygen. So we have to add 6 water molecules and double number of OH minus. That is 12 OH minus here. Now we can see that number of hydrogens are also same, that is 12 hydrogens here and 6 into 2, 12 hydrogen is here. So now we have to make sure that in the both side the charges are same. Here is 12 negative charge and here is 2 negative charge. So from this side we have to extract 10 negative charges, and that can be done by -10 electron. Now we consider the reduction reaction. From here is a number of bromine is 1 and here is 2, so we have to multiply 2, and here is number of charges is -1 and here is 0, so we have to add here 1 negative charge, and that is done by plus of electron, as electron has negative charge, 1 negative charge. And in this process the number of electron involved is 10 and here is 1, so we have to multiply it by 10 so that number of electrons in both reduction and oxidation reaction are same. By doing this we have that's how we can solve a balanced redox reaction.